Okay, good morning everyone, or good afternoon, depending on where you are. My name's Beverly Henry, and it's my very great pleasure to welcome you on behalf of the Scientific and Technical Committee of the 4 per 1000 Initiative to this webinar. I'm one of the co-chairs of the committee. Professor Budman-Manasny, who actually organised the webinar, sends his apologies that he's unable to host today. We'll make a start now. Although some people are still joining, we'll try to keep to time in starting. Today's webinar is the 6th in the Soil Carbon Science webinar series that explores current scientific issues relating to carbon storage in soils managed for agriculture and forestry. The webinar series is organised by the Scientific and Technical Committee of the International 4 per 1000 Initiative, which was launched by France on the 1st December 2015 at COP21 of the United Nations Framework Convention on Climate Change. The purpose of the initiative, which now has over 820 partners and almost 370 members, is to understand and communicate how agriculture, and in particular agricultural soils, can play a critical role in 2 major global challenges of our times: food security and climate change. I invite you to visit the 4 per 1000 website to discover more about this work. But an important aim of the initiative is to help ensure that actions to manage soils, to improve human nutrition and combat the impacts of global warming are based on solid scientific evidence. And the Scientific and Technical Committee webinar series contributes to this aim. It is in this context that today's webinar looks at a topic that has become of increasing interest: the potential role of no-till or reduced tillage farming to improve soil condition and to mitigate climate change impacts through increased soil carbon storage. Today, we'll firstly hear from our 2 very highly respected experts, Dr. Marie-Élise Samson and Dr. João Carlos de Moraes. And this will be followed by a discussion led by Dr. Adsola Olale, a member of the 4 per 1000 Scientific and Technical Committee. After this, there'll be an opportunity for questions and comments from the audience. So if you'd like to type any questions or comments into the Q&A on your screen, we'll aim to get to as many as we can at the end, depending on time. So to start with some introductions. We are extremely fortunate to have Dr. Marie-Élise Samson and Dr. João Sá to lead us in exploring this application and benefits of no-till agriculture in the tropics and in colder climates, focusing on its potential to enhance soil carbon storage. I'll give a brief introduction to both speakers right at the beginning, and then we'll start off. So Dr. Marie-Élise Samson is an agronomist with a master's degree in soils and the environment from Université Laval and a doctorate from Agrocampus Ouest in France and Université Laval. Marie-Élise is an assistant professor of soil science at Université Laval. Her fields of expertise include agropedology and biogeochemical cycling of soil organic matter. Amongst her many other achievements, her work has allowed better predictions of the effect of agricultural practices on crop yield, soil fertility, and carbon storage in agricultural land. So welcome, Dr. Marie-Élise.
Thank you.
Our second presenter will be Dr. João Sá, who is a distinguished researcher in soil science and agronomy. His academic qualifications include a BSc in agronomy from the Federal Rural University of Rio de Janeiro and a PhD in soil science from Sao Paulo State University and Ohio State University. Currently, he is a senior associate researcher at the Carbon Management and Sequestration Center at Ohio State University. and since 2018, he has been the president of the Technical and Scientific Commission of the Brazilian No-Till System Federation. He has over 25 years of teaching experience. His research focuses on soil organic matter dynamics, no-till systems, and sustainable agriculture, with an emphasis on soil carbon sequestration. Welcome, Charles. So I'm sure you'll agree with me that we have a lot to learn from our speakers today. And without further delay, I'll hand over to Marie-Élise. Thank you.
Thank you so much. So, hi everyone. So my name is Marie-Élise Samson, assistant professor at Université Laval, and I had the pleasure to work on that presentation with my colleague, Denis Anger, a researcher that worked at Agriculture and Agri-Food Canada and is now affiliated with l'Université Laval in Quebec, Canada as well. So the presentation focuses on the effect of no-till on soil carbon stocks in the very specific pedoclimatic context of Canada. So, as a brief introduction to the presentation, I'd just like to remind the very important effect of both climate and vegetation on soils in general, but maybe more precisely on soil organic matter cycling. And I wanted to present this an adaptation of a figure proposed by Charlemagne, and that I really like because you really can see here the amount of carbon that can be found in the phytomass in topsoil, but also in subsoil under different climates across the planet. And rapidly here you can see under tropical climates, warm climates, and here I want to drag your attention on colder climates. So here you have cold temperate moist climate and cold temperate dry climate. And of course, you can see that under cold climate, we tend to have pretty important organic carbon stocks in general, but carbon tends to accumulate maybe even preferentially in the subsoil under those kind of climates. And there is also a pretty big difference between cool temperate moist and cool temperate dry. And this is also true for boreal climates. So this is just a little reminder before we start the presentation that both cold temperature and moist temperature tend to favor the accumulation of soil organic carbon in the topsoil, but also in the subsoil. And so more specifically for the Canadian context, well, what does the Canadian climate really look like? Well, Canada is a very vast country. So the climate across Canada is mostly cool, of course, but also temperate in certain regions of the country. It's also a country that is pretty humid, but there are zones where it's more arid. So in the western provinces here, you can see that the climate is defined as cold semi-arid. And in the eastern part of Canada, well, it's the conditions are much more humid. So annual rainfall in Canada, they vary from about 500 in arid regions to more than 2,000 millimeters in the mountains, for instance. So there is a great variability in the climate within the country. But in general, Canada is a cold climate with short, warm summers and very long, frigid winters. It's a country that is vastly covered by the boreal forest, and this has a very profound impact, of course, on soil organic carbon stocks. And there is also a huge proportion of the country that is covered by wetlands. And as you all know, wetlands are very rich in carbon as well. So all in all, it leaves very few surfaces for agricultural soils. Agricultural soils are mostly located in the southern part of certain provinces. So it's very interesting to know that about 80% of agricultural soils are actually located within the western provinces. So these provinces are characterized, as I said earlier, by a more arid climate. And they are mostly these agricultural soils are mostly Chernozems, so organic matter-rich soils under a semi-arid climate and with mostly cash crops and cattle production. The story is very different in the eastern part of the country. So Quebec is where I'm from. Université Laval is located in Quebec, so eastern part of Canada. The climate is much more humid, and it's also very cold. And so historically, the province has focused on mainly dairy production. We also have, of course, cash crops, and we have fruits and vegetables as well. But historically, agriculture was mainly focused around dairy production. And that's very important for the story surrounding organic carbon changes across time in Canada. As for soils, as I've said earlier, so in Western provinces, agricultural soils are mostly from the Chernozemic order, whereas in the Eastern provinces, we have to work with different soils ranging from puddles to bruni soils to clay soils. So once again, different climate in the Western provinces, different crops, and different soil types than in the eastern part of Canada. All in all, though, as I said earlier, Canada is covered with a lot of wetlands, boreal forest, and we are under a cold and humid climate mostly. And so when we compare the carbon stocks in Canada to carbon stocks in other countries, you will find that Canada does have a great amount of carbon, organic carbon, in its soils. And this is a map of soil organic carbon stocks in Canada. And as you can see, like the brown part there represents a surface where there are many wetlands. And so there's the influence of land use, of course. But all in all, even in agricultural soil, there is on average from about 80 to 150 tons of carbons per hectare in our agricultural soils. So they're pretty rich soils that we initially work with. Then what we do with those important organic carbon stocks also greatly matter. So this is a very interesting figure from Fan et al. And it shows the organic carbon stock changes across Canada from 1971 to 2015. And just looking at the figure like that, it strikes you that in the Western provinces, there was an actual gain in soil organic matter during that time period, whereas in the Eastern provinces, we actually experienced a loss of soil organic carbon. So why is that? Well, what you have to know is that in the Western provinces, where there's a lot of wheat and canola, and they have worked with Chernozems, and they have used those soils and tilled them intensively for many years for cash crop production. And around the 70s, there was like, well, no-till was invented, and in the following decade, there was a massive adoption of no-till across those provinces. And so the massive adoption of no-till combined to the abandonment, of summer fallow by the farmers of the Western provinces. It allowed soil organic matter to accumulate in soil because it increased yields, and in this more arid climate context, it really helped to accumulate organic matter at the surface of the soil. And so there was an increase in organic carbon stocks over these decades in the Western provinces. Now there was a decrease in the Eastern provinces. Why is that? Well, there could be many reasons. There was like massive drainage happening in Quebec around the 70s, the 80s. The farmers started to drain their land, and so this could have had an impact, of course, on organic carbon stocks. There is also probably the influence of climate change that accelerates organic matter mineralization under cold conditions. But probably one of the main factor is a major change in land use due to a change in agricultural profile in Quebec. So we have noted that between 2006 and 2020, the province lost up to 39% of their surfaces in perennials, and they gained about the same percentage of surfaces in cash crop. So basically what this means is that farmers that were dairy farmers started abandoning dairy production and turned towards cash crops. And so rotations that included perennials were totally abandoned. It converted to cash crops, so annual rotations. And that really had a major and profound effect on soil organic carbon stocks. So as this new system try to find a new equilibrium, well, we lose carbon from our soils because we've totally changed the type of rotation that was typically applied to those soils. So that being said, knowing that we're shifting towards a greater cash crop production, could no-till be the solution to preserve soil organic carbon in eastern Canada as well, as it's been the case in the western provinces, even if the climate in Quebec is colder and much more humid? So we're going to try to answer this question together, starting with yield. So as you may know, there is a great variability on the effect of tillage on crop yield. And there are many very good studies about that and meta-analysis. And this is one that you may know from Biddle-Co. I'm not sure if I pronounce it well. That was published in 2015. And this meta-analysis was looking at 678 studies from 63 countries. And basically what it says about climate is that the advantage of no-till for crop yields is basically greater under dry rain-fed climate than under humid rain-fed climate, where on average, not always, of course, it depends on many other things, but on average, there is a decrease in yield when under no-till adoption. Why is that? There could be many reasons, starting with soil temperature. So soil temperature is a big matter here for us in Quebec, where we only get a few months to grow crops. So in the spring, we really want the soil to become warmer faster so we can seed and get the best of the growing season that is very short. There is also soil water content that is sometimes too high here. So under no-till conditions, sometimes the soil is even more humid than it would be if the soil was previously tilled. There are also questions surrounding nutrient availability with residue management, and another big issue under humid condition is compaction. So no-till might be good for a lot of ecosystem services, but if the farmers are not careful and go in the field with heavy machinery under wet conditions, then there could be effects on soil physical properties. Compaction, for instance, is a major problem in the province of Quebec right now. That being said, there is absolutely no doubt that no-till represents no-till has advantages as well. So for instance, no-till really has a positive effect on surface soil health indicators, and that is especially when residues are returned to the soil. So this is these are results from a long-term study from Quebec, Eastern Canada, and soils were sampled at the surface, so the 10 first centimeters, and it's an average for aggregate mean weight diameter and microbial carbon of the microbial biomass, an average from 2010 to 2015 under a wheat, corn, soybean rotation. And as you can see, there is a positive effect of no-till of no-till or minimum tillage and soil health quality indicators, especially when the residues are retained. And that's because no-till tends to accumulate organic matter at the soil surface. So when you don't till the soil and return the residues, there is like organic matter inputs to the surface soil layer that activates microbial activity, and that helps with aggregate formation and aggregate stability. So this is undoubtedly a positive effect of no-till over tillage. So could this increase in soil health quality soil health indicator in the topsoil also result in a greater soil organic carbon stocks within the whole profile? Well, what we have observed in this specific long-term experiment is that we indeed see a greater soil organic carbon stock under minimum tillage at the soil surface. So here, minimum tillage in green and tillage in orange. So we do have a greater soil organic carbon stock at the surface layer. But then when you start going down in the soil, 15 to 30 centimeters, there was not much effect. And then 30 to 45 centimeters, well, there was more carbon in the soil, in tilled soil than soils under minimum tillage. And the same thing was observed for the 45 to 60 centimeters layer. So all in all, what we observed is that under minimum tillage, organic matter just tended to accumulate in the surface, versus under tilled soil, organic matter tended to accumulate in deeper soil layers. And this is not just a result that we've seen in one experiment in Eastern Canada, but it really is a typical result in cold and humid condition. And I just want to bring back this graph here that is from Angers et al. 1997, and it's an average from 7 sites across Eastern Canada. And they observed exactly the same thing on these 7 sites. So the reason why this happens in Eastern Canada and it didn't necessarily happen in Western Canada is because the conditions here are so cold and so humid that the organic matter that is brought to like 15, 20, 30 centimeters in the soil with tillage, it just tends to accumulate there because it's just like if it was put in a refrigerator where soil microbial processing, like microbial activity, is decreased because of the temperature. And so it just accumulates there. So when you look at the whole profile, there is typically no difference between soil organic carbon stocks when you compare minimum or no till to tillage. So in conclusion, and a little bit of perspective as well, I think what we have to take from that is that when you have different climates, you can use the exact same agricultural management practices and have very different outcomes. And that's just how things work. So this is the sphere here has 3 axes, but there could be many more axes to the sphere with like socio-economical factors or whatever. But I just wanted to show here that the effect of soil tillage varies with pedoclimatic contexts on different levels. So the red dot represents a dry and warm climate where no-till could, for example, increase surface soil health and increase crop yields and increase carbon storage. But the exact same practice under cold and humid conditions, so the black, not the black, the blue dot here, well, the outcome could be to be an increased surface soil health, but maybe a little less crop yields. And in terms of carbon storage, there would be no effect at all. So I think it's very important to, when we try to find strategies to manage or increase soil organic carbon stocks, we really have to think about what kind of soils and climates and plants we work with, because the solution is not always the same for every agroecosystem. And in terms of perspective, I'd like to bring back a part of this little figure I started with, just to remind everyone that under cold and humid conditions, we have a very high amount of soil organic carbon in soil, but also in the subsoil. And typically, we see subsoil as a repository of very stable organic carbon that is not affected by agricultural management practices. But in a recent study that we conducted in Eastern Canada, we observed significant losses in subsoil carbon in Eastern Canada, and with significant effect of agricultural management practices on subsoil carbon stocks. So we really saw that management practices could have an effect on subsoil stocks, probably because of the very humid conditions that favor the transfer of organic matter and nutrients through the soil profile, whereas under drier climate, this transfer might not be as important. But once again, just trying to be careful in dragging conclusion. I'm looking for the right term here, but concluding things based on a specific pedoclimatic context, because all realities are different based on the agricultural reality and the pedoclimatic context you work with. And so on that, I thank you for your attention, and I'm really looking forward to hear what Joao has to say about no-till in a different context.
Thank you so much for that presentation, Marie-Élise. It was an excellent presentation and a great reminder of the complexities of the relationship between soil organic matter dynamics, management, and climate. And I guess the caution that we shouldn't disregard context-specific issues and extrapolate from one study across your whole country.
Yeah, thank you for saying it properly. I could not find the words. Thank you.
You said it beautifully. Okay, thank you. I'll now hand over to Dr. Joao Sa and ask him to continue this interesting discussion. Thank you.
Hello, everyone. First of all, I'd like to thank the organizer of 4,000 meeting. It's a pleasure to be here to share our finding research in the last at least 3 or 4 decades. Well, let me share my screen. Okay, currently I'm a senior research associate at Ohio State University. And I'd like to discuss about no-till agriculture and carbon storage in tropical and subtropical in Brazil. The presentation of Marie-Élise was very nice because we are living certainly in the opposite sides, opposite country, opposite climates, and it's very interesting. We heard something about the very cold climates. First of all, I will do a little short overview about no-till system in Brazil, emphasizing 2 points. First of all, a quick glance about conservation agriculture in the world, and the publication that was done by Kassan and colleagues in 2022, and in that time, we had 1.59 billion hectares in cropland surface as annual crops, and around 205 million hectares, or 0.2, in conservation agriculture. That represents 12.9% of the whole cropland cultivation with conservation agriculture. That means that almost 90% use plow to grow the crops. If we see around the continent, so we see that Oceania, Asia, South America, and North America has the most expanded, most important areas in no-till. And 52, almost 53% is located in Brazil and US and Canada. The second thing that I'd like to emphasize is the importance of no-till for Brazilian agriculture. We started no-till in 1972 with 200 hectares, and in our inventory in 2020, we reached 36 million hectares, mainly with the animal crops, and plus 7 million, including sugarcane and integrated system. During this time, we had a lot of challenge to overcome, and currently, from these 36 million hectares with annual crops, we have only 10 to 15% fitted in the concept of no-till system. This is very important because us from the Brazilian No-Till Federation, we classify conservation agriculture like a pyramid, and the top of this pyramid is a no-till system. What it means, no-till system for us? We consider that based in the three principles of conservation agriculture: absence of plow, except of a seeding line. You can see this picture, you can see only the sowing line. The second principle is keep the soil covered all the time. This is a pre-harvest corn, and the soil is almost 100% covered, waiting the new crop residues. And the third principle is the diversification of crop rotation. With these three principles, we consider no-till system. Okay. The other thing is Brazilian agriculture. If we think from 1966, we had 46.9 million tons of grains, and in 2022, 322 millions of tons. We increased it around 6.9 times the production, and the land expansion only 2.1 times. But if you ask why only 2.1 times, if you heard about the media that Brazil implies a lot of clearing areas and expanding the area, but important information when we plot the evolution of no-till, coincidence with the linear curve of grain production and the no-till expansion. It is very important because I will explain a little bit ahead. Well, I'd like to divide it into two scenarios, this presentation. Published results based in long-term experiment. I have to say that Brazil is around almost 90% in the tropical areas and less than 10% in the subtropical to temperate areas. These results, I try to develop a timeline, emphasize some important publication during the time. The first one in 1998, one observation in southern Brazil for these two authors is they posted that we have around 0.37 tons per hectare, but in the shallow or in the 0.10 centimeters layer in 10 years with experiment. The second important result from Coraza in Cerrado region in 1999, and he posted that a 0.5 tons per hectare per year in the 15-year experiment. After that, a colleague from Rio Grande do Sul published a very nice data that we included legume when he mixed it with another crops and improved carbon sequestration. And also, he observed in a little more depth, until to 30 centimeters layer. In 2001, our group published that in a chronosequence, we found that around 0.81, 0.99 until 0.40 centimeters layer. And another work using many kinds of a combination, they obtained around 0.59 tons per hectare until 30 centimeters. Well, this article published by Carlos Seri, he did a very nice job because he grouped all information since 1992 until 2005. And he created like a table and summarized all sequestration rates in many situations. In that time, the results showed that we had a weighted average for Brazil estimated in 0.5 megagrams carbon per year. Okay, that was a very good, inspired a lot of research, also me, to discover and try to understand a little bit more what's going on in the different regions. Okay, in 2009, this colleague Tornkes adjusted the method from the EPCC and also some modeling like a sensor for our condition and created opportunities to understand the environment, the different environments in Brazil. In 2013, again, we published the first inventory of the carbon and nitrogen in landscape situation. We did a comparison between no-till system and native vegetation, and we developed a methodology applied for the landscape that advised us many things and many options and guide us for the new experiment. Well, after that, a lot of authors did a very good contribution. Based on this, I tried to summarize them. In 2023 to 2024, we joined with other people, and we did a very detailed survey based on all publication that was presented in Brazil, and try to select the main two regions, the tropical and the subtropical. And in this survey, we selected 60 scientific articles with 117 observation. We try to extract the observation that have a rotation, not only double crop like corn and soybeans or soybeans and wheat in the southern Brazil or the tropical area. And we grouped this information and we obtained a very interesting situation. And we distinguish tropical and subtropical. In tropical, the weighted average was 1.37, completely different from the scenario from 2005, and the subtropical for 0.96. This is what's very important because we understood that what's happened, what's caused this increase, and we tried to separate some points that impacted more. Based on this, we developed a farming project, but before we tried to group these results by layers, and was very interesting because according you are increasing the layers, for example, 020, 030, 040, 000, you increase the sequestration. Okay, of course, it's illogical because you are integrated layers, and but there in Brazil, we have a very important uh, cause that can change the root system because we are using some species that have a high potential to develop roots for 1.5, 2 or 3 meters above. Well, uh, now I'd like to present the vision or the approach of a farming system. I'm coordinating a project that started in 2020. That this project was sponsored by European funding agents, Euroclima Plus, is a partnership between the Minister of Agriculture and Livestock and the Euroclima Plus. And this project, we sampled 63 sites in the two biomes, Cerrado and Atlantic Forest. The objective was to complement, to try to extract the information that what's going on, the real situation. And each site, we selected 3 land use. Native vegetation represent the pristine stage. The plow-based tillage is a degraded area, and no-till system based on the concept that I presented before. And we sampled, we got around 3,402 disturbed and 3,402 steel rings to calculate the bulk density in 6 depths, 10, 20, 40, 60, 8 until 100 centimeters layer. Okay, based on this, we only a brief description. What we understand, native vegetation is an undisturbed and preserved soil for each location and have a steady state of carbon, and plow-based tillage is intensive soil disturbance that causes annual plow and reach a new equilibrium, but in the lower level. And the third use, land use, is a no-till, involves the 3 principles that I said before, and restore continual flow of carbon nitrogen, leading for the new steady state. And we select areas that have at least 20 years of continuous no-till. In the 63, we have areas from 20 to 49 years under no-till, or no-till system. Okay, we classified, we grouped this area based on the concept of cluster. That means it's a group of similar items that occur together. We got a huge database with the environment, core variables, soil type, precipitation, temperature, elevation, slope, with 1 million numbers. And we group it in 13 zones or 13 clusters or ecozones and have a specific characteristic. For example, we have 4 main climate zones, and the clusters is divided in the zones. We have the tropical equatorial, only to share the mean annual temperature in the tropical equatorial is 26.6. The mean annual precipitation varies between 1,200 and to 2,000. It's a hot, humid, and other is a tropical center, subtropical humid, and subtropical temperate. It is based in the maps that we adjusted for each site and each cluster. Okay, now the result to show is a very interesting response. First of all, the native soil. If you see, is organized by cluster. We had the latitude starting from 7 degrees to 28, tropical, include equatorial and center, and subtropical, humid, and temperate. The first thing that we observed is a trend based in the clay. Okay, 1, according you increase latitude, carbon increase. According you increase clay, carbon increase. This is well known, and these components impacted in the carbon storage. But interesting that the patterns of the losses based in the plow-based tillage was similar according to the climate, according to the core variables, and the latitude and the climate zones. And we lost 21.8 to 55.5% of carbon when we convert native vegetation and keep plow-based tillage. This is based in the 13 cluster. If we plot the 63, we have a strong variation, but this we integrate an analysis that calculate this variation. And the no-till system, well, if you see, is most similar with native vegetation, and it was one of premise that we proposed in the beginning of the research, because we are comparing some things that try to mimic the modern nature, that in our situation, we are integrated this systemic approach. And no-till provided an historical restoration based in the 63 places, 72.7 to 103%. That means in many situations, we storage more carbon than the mother nature or the native vegetation soil. And the historical sequestration also was at 48 until to 105%. That means that we in some situation we double or a little more the carbon lost by plow-based tillage. And in 5 clusters, we have no statistical difference between no-till system, soil, and native vegetation. Always we are talking about 0 to 100 centimeters, but we have a lot of data stratifying the profile. Okay, we group this information and in a simple figure in 4 classes. The soil carbon restored by no-till compared with native vegetation. 14 sites, so 22.2% of the all sites recover 60 to 70% of the original carbon. Also, again, all other 14 sites also recover 22, 80 to 119 sites. In the same or above 100% is at 16 sites. That means that if we sum 80 to 100% is a 15.5. This is a new scenario. It's a very interesting because now we create like a web. We are create zones that we can compare and we can simulate the carbon storage based on this information. And why we can, especially in the tropics, accumulate or storage more carbon than the mother nature. If you see, is one of the main species cultivated there called brachiaria. We have a lot of types of brachiaria, and the root system goes to 1 meter, 1.5, 2, and sometimes 3 meters. And you can see is a plateau of Bahia. It goes to 1.5 meters. The soil completely covered. Another situation, and we can see very good root system in 30 meters. And this picture for me is very interesting because mix and confound the roots. It's very difficult to see what is soybean, corn, or brachiaria roots. It's the principle of the system. How much more you develop roots, try to occupy the porous system is much better because you are adding carbon in that. Okay, summarizing our presentation, this is also the information that group duration of no-till system against the total carbon sequestered. And you can see that the orange represent tropical and blue represent subtropical. And now we have the scenario 1.72 tons per hectare per year is with this farming system approach. What it means, what is our current situation? We started from 2005, 0.5 megagrams per hectare per year is all observation that was done in that time. 2023-24, we increased in subtropical and tropical for 0.96 and 1.37, and current based in the farming system in a robust database 1.73. That means no-till system for the tropical and subtropical region have a strong potential to recover carbon and also be eligible to contribute to minimize the climate crisis. You know, this is approach that we are trying to do. And what next? Well, we try now to expand the cluster approach because we have a lot of different kind of micro regions, and it is very difficult. We spread only one like a certain. Oh, what is the sequestration rates? Oh, now we have to ask for when, where, uh, uh, and what is the basic conditions. Comparison of the reference. We needed to define the reference. We are now trying to select much more areas with native vegetation and plow-based tillage to create a web that can give us more capacity to expand the results. And the interpolation and create like a web. And finally, we are calculating the uncertainty rates between the boundaries in the clusters. With this, we believe that we can give a, a, a very important step forward and understand better no-till system and create a condition to do suggestion to improve the production system and minimize the climate crisis. And coming soon, I think is the end of October, November, this paper that with this research results. And I'd like to give a huge thanks of all this carbon team that work a lot and a huge contribution. Thank you so much. I hope that I can give information that can help you guys.
Thank you so much, Joao. That was another very interesting and an excellent presentation. So much to think about in that, and particularly just sort of understanding the potential for restoration of lost soil carbon due to past practices is a really important issue, and it may be one that Ola is looking at, because I'm about to hand over to my colleague from the Scientific and Technical Committee and to lead now a discussion of some of these points. Thank you, Ola.
Okay, thank you, Marie-Élise. Thank you, JC, for this beautiful presentation. I think I've taken in so much in terms of what to digest. However, I think I want to structure the question in such a way that at least it cuts across the two presentations. So I'm going to start from Marie, and it's actually in tandem with one of the questions on one of the participants also. The first question has to do with the role of herbicides use in no-till system, because definitely to control weeds, you need to definitely use herbicides. So what is the role of herbicide in no-till system? And what is the impact of this herbicide on the biodiversity of microorganisms, as well as groundwater nutrient content? Thanks.
Yes, it is a very good question that is not specifically in my area of expertise, but what I can say about that is that there is really an issue surrounding pesticides use with no-till. We can even feel it from the farmers. They're like, there's a division between farmers who use tillage and no-till farmers, and they're gonna argue one against the other, mainly around pesticide use. And so and I think it brings us back to this fear that I showed, you know? There's no silver bullet that's perfect in every kind of way for everything and every ecosystem services that you can think of. There are drawbacks for certain practices, and I think it's up to the farmer and to try to find the best management practice in their specific context to increase the services that they want to increase, you know, because there will be drawbacks, whether it's pesticide use and there are ways to counter that. I'm not sure I can say that, but of course, people will say, well, using cover crops, you could reduce the use of herbicides under no-till production. And yes, there are ways to do it. Probably, but there certainly is no silver bullet. There will be drawbacks somewhere, I think, in my humble opinion.
Okay.
Yeah.
Thank you for that. Then, okay, JC, can you add to that from Brazilian perspective?
Okay, it's a very interesting question, because again, if I back for the parameter, we started from the principle of no-till, and within the no-till system, we have a no-till with grains, integrated system, livestock and grains, and integrated system, livestock, grains, and forest. And now organic no-till.
Okay.
If we have 10% under no-till system in organic, we have maybe less than 1% in Brazil. That's what it means. That we are trying to use cover crop, intensify, close the window between rainy season and dry period, and keep the soil 100% covered. I will give you an example from southern Brazil, one of the oldest no-till is around 37, 39 years, and here it is, 80% of herbicides, 50% of insecticides, 60% of fungicides, and 90% of industrial fertilizer. He using the whole system. Okay, is it for everybody do this? No, but it's possible. We have to re-examine our mind. We needed to add the systemic approach that the physical, chemical, and biological attributes in the soil works together.
Okay, thank you for that. So the reason why I'm asking the question now is in terms of scalability to developing countries, which I think what Marie-Élise presented, I think is a micro section of Canada has a bit of a maybe subhumid, and then I think Brazil has so much that can actually be extrapolated to developing countries. So what do you advise to do in that scenario? So I will start from JC, then I'll come back to Marie-Élise later.
Yeah. Well, once again, yeah, I'm from Eastern Canada, so I have more expertise under cold and humid climates. But of course, what we've learned from the more arid part of Canada is that no-till can indeed be a good solution there because of the mulch effect that keeps water in the soil, covers the soil, and yeah, it locks more moisture in the soil, and it always comes comes back to what is the limiting factor. You know, the image of the barrel that we often see for fertilization, where nitrogen is the limiting factor and water flows out of the barrel through the plank that is linked to nitrogen. Well, I like to see this barrel not as like nitrogen, phosphorus, potassium, etc., but it could really be anything. It could be a compaction, it could be a lack of oxygen, it could be a lack of water. So what's the limiting factor in a specific system, and what can I do to make it better? And that really is the big question. So if there isn't enough water in the soil for the plant to grow properly and for yields to be good, then let's focus on that. And can no-till be a good solution for that? Well, yes, of course. So let's just try to cover the soil, keep moisture locked in. But it's so context specific is what I've learned anyways from working with different soils. You know, even in Quebec, we work with like very heavy soil, very rich in clay particles, and we also have like sandy soils with low pH, and these two soils, you don't treat them the same way, even under the same climate. So it's just so specific that it's hard to give a broad answer that applies everywhere, I think.
Okay, thank you for that. Okay, Jesse, can we hear from you?
Okay, I think that the most important that I'm saying this was the learning that we had with this project to understand clusters, climatic zones. Before, if you back 10, 20 years ago, when we're talking about carbon, we're talking about the sequestration rates, we never specify the environmental variables. This is very important. And I think, for example, what I'd like to suggest for developing countries. I'm located between latitude 0, equator, to 28. If we extend this range, we pass to Africa, we pass it to Southern Europe, we go to Asia, we go to the Oceania. You know, what the most important we do in the near future? Try to characterize climatic zones and crops with possibilities to grow crops. With the algorithms that we have today, powerful algorithm, AI, and remote sense and modeling, we can define these climatic zones and be more specific and suggest production system that can be more stable and can produce more for this kind of region. I think this is the start point to define climatic zones in many situations, cross with the crops, and add the soil management or to introduce a no-till system.
Okay. Then I think it's, as a follow-up, are there any collaboration with other scientists from developing countries with respect to some of these projects? I think with Marie-Élise as well as Jesse. Are there collaboration? Because I think there should be transfer of knowledge. If you can be able to bring some of these colleagues, maybe PhD students, postdoc fellows, you know, onto your team, they can actually go back home and be able to want to try to replicate some of this that you are doing, and then there could be more or less maybe comparative analysis over a period, maybe subsequently. Let's start from Marie.
Yeah, of course, it's a great idea. And I personally have been in my position for 3 years only as a professor. But of course, there's no point in like doing your little research in your corner and that like wanting to share and expand and yeah. So I hope it will be a focus for my future research, indeed. And I think that's where research in a broader sense is going to, is collaborations, interdisciplinarity, etc. So I think that's where we're going, and that's where I hope I will go too.
Okay, that's cool. That's a cool one. Okay, Jessica, because you seem to have a large team from your end. So what efforts have you, or are you trying to make to bring in maybe scientists from, or PhD students from South Africa, maybe from Niger, maybe from Morocco, and from maybe Thailand, onto your team? It's going to be interesting.
Yeah, I think, Ola, that one important point is we start to standardize protocols. You are a soil scientist, and Mary is the same. When we look at the literature, we have a lot of alternatives. We have a lot of names. We have a lot of description. But if we squeeze and we join everything, we have a lot of common points.
Yeah.
I think it is a time that we standardize protocols. For example, we are trying to spread this protocol that I did in this project in Argentina, Uruguay, Paraguay, Bolivia, and Mexico. And also we are trying to contact with people from Asia, Thailand, Cambodia is the partners that we have, try to spread the same protocol. After that, we have a condition to compare.
Okay.
And try to define some, let's see, advanced lines, or advanced knowledge. And after that, try to postulate the next steps, because we have a lot of accumulated knowledge. Soil science is a rich field, and I think the most difficult point is extract, and join.
Okay.
This is
That's cool. That's cool. Thank you. Then I think before I will take the question from the Q&A, what about the economic viability in terms of no-till? So how much goes into it? Has there been economic studies with respect to maybe from Canada, from Brazil? Because if you look at that from the lens of developing countries, we are coming from maybe from Thailand, for example, you are coming from Niger, for example. Where do we get the money to fund such projects in terms of adoption? I think we start from Marie-Élise.
Yeah, that is another great question. And I find very hard to find good answer to these questions personally. I know that in Canada, it's very hard to know. There are so much variation in the price of the grain, the price of fuel, the price of tractors. Every year is just so different in terms of payments and incomes for farmers that it's very hard to find very good economical studies on agricultural management practices, and to be 100% sure that you make more money if you adopt no-till year after year, or vice versa for that matter. And that's just my personal point of view on that. I know that in conferences for farmers or counselors and stuff, we rarely hear presentations about the economics, and that's just because farmers, they're so busy doing everything else that they don't have time to know exactly what type of money went into this field versus this field, etc. So just a few farmers keep very good books about this. So it's very hard to answer once more. It depends on so many different factors.
Okay,
Sorry.
okay.
No.
Thank you. That's cool. That's a good one. Okay, Jesse, do you have in terms of economic viability of no-till farming from your perspective? Have there been economic studies? Because as we collecting this data in terms of soil organic carbon, groundwater, biodiversity, can we bring in economists, agri-economists, or economists on board to be able to look at the economic viability of these practices, these studies?
Okay, I will divide it in three scenarios. The first scenario was a publication that was done for IAPAR, is a Southern Brazil Research Institute located in Paraná, that in the beginning of the 80s, they compared all components of the cost, conventional tillage, and no-till. And they affirmed that no-till system can reduce 10 to 30% less the costs. Was a very important information that motivated a lot of farmers switch from conventional to no-till. The second one is a monitoring that we did in the last 4 years. I visited 53 farms, and I did a monitoring in 2 farmers. It's a completely detailed during 5 years. We took information about all crop history, inputs, outputs, and we did a carbon balance. And we compare no-till system with intensive rotation. For example, one system with 12 species: corn, soybean, rice, and mix between cover crops. And we compare with double crop. What double crop? Soybeans and corn. Soybean the first crop, and corn the second crop after harvest soybeans. The profitability between no-till system and no-till system based on double crop was 40 to 50% higher. Is impressive. Why? Because we acted in many aspects. We reduced costs, herbicides, fungicides. We saved water, and we increased yield. In the end, we stored more carbon. And the balance was very favorable for no-till system. The bottom line, if you invest in diversity and a system that can perform more yield, you have more profitability. And the third, we published in 2022 a paper that we compare these 2 systems, and we try to monetize in carbon. And what's very interesting that we try to compare 1 hectare under no-till with 1 hectare under conventional and 1 hectare under native vegetation. And we concluded that if we develop a full no-till system, we can preserve 1.3 to 1.4 hectares in the forest stand. We don't need to, to deforest. That's what's important. You relate cropping system, agriculture system that can produce food in harmony with Mother Nature. Okay. When integrated all things.
Yeah, thank you for those responses. I think we have about 7 questions. Okay.
Sorry.
Beverly.
I'm sorry to interrupt. We had two attendees with their hands up. I think they've both gone down now, but one was Dini Angers, but we can follow up later. And Professor Ratan Lal also had a question, which is now in the chat. Samuel, are we able to activate Professor Lal's microphone so that he can ask his question? Professor, please go ahead.
Just wanted to congratulate you. That was very, very good presentation. Both of you were very, very excellent presentation. You were always talking about plow tail and minimum tail. And Professor Shah was talking about plow tail and no tail. I just wanted to make sure that was your minimum tail the same thing as his no tail was, or you did not have a no tail?
Yes, thank you for that question. I guess it depends on which graph we're talking about, because there was this graph where Denis Angers compared different systems, and that was no-till versus tillage. In the other study that I presented, where I compared minimum tillage to tillage, well, it was a much more complex experiment with 3 levels of factor, including tillage intensity, residue management, and fertilizer source, including 3 different organic manure, 3 different manures and mineral fertilizers. So minimum tillage was in fact kind of a no-till system, but since we worked with manures, we just wanted to integrate a little bit the manures at the surface of the soil to avoid too much nitrogen losses. And so it was just like maybe 2 centimeters where manures were incorporated into the soil. And as for, was it really no-till? Well, it depends on what you see as no-till. So as I just said, half of the experimental units, residues were harvested, and on the other half, residues were returned to soil. So we could really see the effect of 20 different combination of management practices, including tillage intensity, residue management, and different fertilizer sources.
Thank you.
Thanks.
Yeah.
Okay.
Okay. Are we done? Any other hands raised? I think we should continue because we have some question here also. There's a question from Lodi in Brazil. The question is, what are the main challenges Brazilian farmers face in adopting the no-till system?
Ola, please, could you repeat the question because the audio was a little bit.
From Lodi Borges from Brasilia, he said, what are the main challenges Brazilian farmers face in adopting the no-till system?
Yeah, this is a very nice question because, how I said, we have currently 36 million hectares under annual crops. Only 10% or 3.6 million under no-till system concept. What is the challenge? The challenge is try to convince the farmers by the #1 point that attract the farmers: money. If we prove that we are proving now that the investment in the diversification, in the complexity of the system, you make more money. This is the challenge #1 because, you know, farmers heard in the first time how much money they can make. You know, and if we broke this barrier, we can step forward. The second challenge is to typify in Brazil, based in the different climatic zones, the different kind of a production system. Not only like a recipe, you know, we needed to define strategies For example, if you are in the border in Mato Grosso and Amazon, there you have a hot climate all year long, rain a lot, and the decomposition rate in sometimes there is around 5.5 to 6% a year. It's like a biodigester. Nothing stays, not, the cover crop. In this case, adapt for each region. The third strategy is to show that no-till system can improve much better your actions, your planning, your work in your farm. You be more organized and you lose less time, and you can use the extra time for other things, because you can plant in the right date, you can harvest in the right date, and create a routine. Okay, 3 things that we can improve. And the last one is show that the farmers can preserve the land for the future generation. Is the bonus. But if you show it in the first time for the farmers not follow, because they heard first money. But the bonus, and for the society, for the world, is if you invest in biodiversity, if you invest in carbon, have more resilience, more productive, more profitable, and preserve the environment.
Thank you. Thank you for that. I think, Marie-Élise, there's this question for you. The presenter, I think somewhere from Quebec here, he or she said, from the first presentation, the practice of no-till is closely dependent on climatic conditions. No significant result for cold regions. In case, can we still recommend this practice to farmers in Quebec as a carbon sequestration practice?
Oh, sorry.
Could I just come in there? That's a really important question. And I will ask you, though, to be fairly quick, if you wouldn't mind, Marie-Élise, because we're coming to the end of our time. But it's important that we get this question through. And thank you, Lola. And I'll close up after that.
Okay.
Yeah, of course. Yeah, the short answer is that if the purpose is to increase organic carbon stocks in Quebec, I wouldn't recommend no-till first, because that's not proven to work under our conditions. So there are other ways that could be used to increase organic carbon stocks in Canada, but no-till would not be the best solution for that, which doesn't mean that it could not have other advantages, such as improved surface soil health, for example, reduced erosion, etc. But with carbon goggles, not necessarily.
Thank you.
Thank you.
Over to you, Beverly. Thanks.
Thank you so much, Ola, for leading that discussion. I'm sure there'll be a lot of interest from the audience in that, and I've got so many questions that I'd like to ask as well. But our time is up, so we'll have to wind up the webinar. And I'd like to firstly just thank both of our guest presenters for their very excellent presentations and insights into the complexities and the opportunities for no-till and reduced-till farming practices to both improve soil condition and yields in some cases, and to increase carbon storage in agricultural soils in other cases. But it is complex. Thank you, Marie-Élise, and thank you, Joao. Thanks also to Ola for his thought-provoking discussion. I thank all attendees for their attention and their presence and for their questions. And finally, I thank the 4 per 1,000 Secretariat for setting up the webinar, which is, without that, it wouldn't work. Our next webinar is planned for late October. So would you please look out for that? You'll get an email about it in the coming days. And If you'd like to revisit today's webinar, it will be online shortly, along with the previous 5 webinars that are there. So you can listen to them and look at them again at any time. I've also been asked very briefly, to just take this opportunity to inform those online that the 4,000 initiative has launched a new call for funding and invites everyone to become a benefactor or donor to support their mission to promote healthy, carbon-rich soils worldwide and to enable webinars like this to occur. So if you're interested, you can easily do so through the link that's been shared on the chat line. And with that, I wish you all a pleasant rest of the day. Thank you again, and we'll close now. Thank you so much. Bye.
Thank you.
Thank you. Thank you. Bye-bye. Bye.
Yeah.
Bye.
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 Congrats for everybody.
Thank you.
Thank you.
Bye.
Bye.